Lesson 6, Distance along Great Circles. We shall begin this lesson by considering the radius of a parallel of latitude. Let the radius of a small circle of latitude alpha degrees north or south of the equator be arrow. That is small letter arrow, and let the radius of the earth be capital arrow. We wish to establish the relationship among radius of a small circle, radius of the earth, and alpha, the angle of latitude. We have the earth as a sphere in this form. You have the equator, latitude 0 degrees. Then we have the small circle up the equator. We have point PQ. This point PQ is latitude 0 degrees. Then we have Q. Q is a small circle. Then from this Q we have this point. So B here is the unknown latitude. It is a small circle. So the angular displacement between P and Q is alpha. From here to here is the radius of the earth, because the equator passes through the center of the earth. From the diagram above, longitude NQPS is any longitude that cuts the latitude alpha degrees north. O is the center of the earth to point P is equal to capital arrow, the radius of the earth. TQ. No, this is a small circle, so the radius is arrow, that is radius of latitude. From the above diagram, we have this other diagram. This is capital arrow, radius of the earth, radius of the small circle. This is the angular displacement between P and Q. It is also equal to this angle, alternate angles. In triangle TQO, QO is equal to arrow. QO is equal to arrow, radius of the earth. TQO, angle TQO is equal to angle POQ, equal to alpha degrees, alternate angles. It follows that in triangle TQO, cos alpha is equal to TQ, that is adjacent over hypotenuse OQ. Adjacent over hypotenuse, that is cos alpha. TQ is radius of small circle, then OQ radius of the earth. We are interested in the radius of the small circle, radius of a parallel of latitude, multiplied through by the radius of the earth to clear fraction. You have radius of parallel of latitude to be equal to radius of the earth times cosine of the angle of latitude, where radius of the earth is equal to 6,400 kilometers. it is a constant value. Distance along great circles. Since the distance between 2 points on a sphere lies on an arc of a circle, we use the arc length formula in finding such distance. Hence, distance along great circles is given as theta over 360 degrees times 2 pi times radius of the earth. Here, a great circle is either meridian or equator. Examples number 14. Find the distance apart measured along great circle of the following latitude. A. Latitude 52 degrees north, 68 degrees north. B. You have 2 points. A. Latitude 0 degrees, longitude 14 degrees west, and point B, latitude 0 degrees, longitude 26 degrees east. Solution. A part of the problem, let the distance be y and the angular difference be theta. The distance is along great circle, obtained using this formula. The 2 points are on the same sides of the equator. Hence, their angular difference is through subtraction, and you have theta to be 16 degrees. You come here, you have y to be equal to 16 degrees over 360 degrees times 2 times pi 3.142 times radius of the earth. When you simplify, you have this result. To the nearest whole number, the required distance is equal to 1,787 kilometers. B part of the question, you have the distance between A and B. Even without mentioning great circle in the question, the presence of 0 degrees means the equator, which is a great circle. So distance AB is obtained using this formula. The angular difference is through addition because the 2 points have the same latitude but different sides of the prime meridian. When you add, you have 40 degrees. Distance AB is therefore equal to this. You replace all the parameters with what they stand for in the formula. When you simplify, you have these results. To the nearest whole number, distance AB is approximately equal to 4,469 kilometers. Example 15. 2 points P, latitude 40 degrees north, longitude 22 degrees east, and Q, latitude 40 degrees north, longitude 22 degrees west, are 2 places on the surface of the earth. A third point is T, latitude 28 degrees north, longitude 22 degrees west. Calculate the distance between Q and T along the lines of longitude. Take pi equal to 3.142 and radius of the earth as 6,400 kilometers. Note that half meridian is longitude, and as such, lines of longitude, the distance is along great circle. If you have followed previous lessons, this diagram represents the information. Precisely, lesson 2, 3, 4, and 5. Distance QT is along great circle given by this formula. The 2 points are on the same side of the prime meridian. You have to subtract to get their angular difference, and that is 12 degrees. You come here and replace all the parameters with what they stand for. You have this result. After simplification, you have this result. To the nearest whole number, distance between Q and T is approximately equal to 1,341 kilometers. Example 16. Calculate the distance traveled by a plane going to this city with the given information, from this city with the given information, by going on a great circle across the North Pole. Pi equal to 22/7 and radius of the earth equal to 6,336 kilometers. Solution: the distance is along great circle. Since the great circle is across the North Pole, we simply take the given latitude as the angular difference, that is 60 degrees, not considering the longitude because of this condition. Distance LA is therefore this. You come here and replace all the parameters with what they stand for. Now, by default, the radius of the earth is 6,400 kilometers. But if you have any other value given to you in the question, you work with that value, not the default value. When you have no value given at all, you can use the default value. Hence, we have it in this form. When you simplify, you have this result. To the nearest whole number, or 3SF, to 3SF, the distance LA is approximately equal to 6,640 kilometers. End of lesson 6. There is every need for you to be saved if you are not, because the Lord Jesus Christ is coming very soon. Some will be taken and some will be left. Live righteously and be prepared. Goodbye.